Welcome to Khetz tutorials, and in this video I'll be doing sigma notation. Now this is the uppercase Greek symbol sigma, and in mathematics and other science related fields this denotes summation. This is actually going to help us to actually show series in compact form, and this is what I mean. So this can be said to be the summation of the sum of the values which you substitute from 0 up to n. So this is your starting point. So here you're basically going to have a formula, whatever formula you have here. Wherever you see the variable k, in this example you just only have k, wherever you see the variable k, you are going to substitute values from 0 to that, incrementing by 1 as you go along. Which means if this is from 0 and at the top, so this is your final value or your last term or last substitution, so let's just say last, and this is your starting point, right? So if we were to say k is equal to 0, which is that at the bottom, and this can be any other variable, just so you know, and at the top, let's say we had n equals to 4, then you basically have, or you basically substitute and say that this notation is equals to 0 plus 1 plus 2 plus 3 plus 4, right? So this basically says you have the summation of the value which you get after substituting all the values from 0 to 4 into this as you increment each of the values by 1. As you can see, the difference between that and that is basically 1. You can also have another formula here. Let's say you had 2k subtract 1. You can basically do the same thing. Wherever you see your k, just substitute the values which you're going to get as you increment by 1. So starting from 0, then the result over here would be 2 substitute 0. So all of this added to the next one. So let's say from 0 to 1, you basically just have these two terms, right? Then you add these, and that'll be your answer. So to find the number of terms from the starting point, whatever the starting point is, so it's not always 0, it's not always 1, right? So to find the number of terms in your series, so number of terms, you're going to take the top number, which is your terminal number, or where you actually stop, and then you're going to subtract the variable at the bottom. In this case it's k, then you're going to add 1, right? So for this one, the starting point is 0 and the end point is 1. So let's find the number of terms. We're going to say n, which is 1, subtract k, and then plus 1, which means the number of terms is 2. If you were only to look at this and say 1 subtract 0, that would be wrong, because as you can see here, from 0 to 1, which I just showed, you actually have 2 terms in your series. And this is the correct formula to actually find the number of terms when given a series in sigma notation. So to solve such problems, there are 2 ways. You can first, so if this number is basically small, you can just expand and add with your calculator. Let's say you have from 0 to 5, from 0 to 6, or whatever, and you can just simply substitute into your formula so you won't make any mistakes. You can just add all of those, and that'll be your answer. Alternatively, if this actually starts at 1, then you can use the sum, depending on the kind of formula which you have here. So at first, you have to identify what formula you have here, right? So in this case, we can actually kind of see that this is some sort of arithmetic sequence, or whatever the case may be. So first, identify whatever that is, and that is if you want to use the second method. So this is the first method, and you are basically just going to substitute all your values and add them up if you can, or if they're actually short. But if you want to do everything all at once, you are going to substitute. If it started, so let's have 2 cases. So case 1, if your sigma notation starts at 0, you are first going to compute the value at 0. So compute value at 0. And this is why. In the second step, you are basically going to use the summation, which we did in the previous section when we talked about series. So you're going to use the formula which corresponds with the equation which you have in here, right? Depending on what type of sequence or series which you have here. So you're going to find a formula for the series, and you know that the formula actually works for numbers which are greater or equals to 1. So you can't start the sum at 0 for this kind of formula. So first, you're going to find the value at 0, and then last, so you're going to add 0.1 and 0.2. So if you find the value at 0, then you find the values from 1 up to the terminal point over here. And to do that, you have to find the number of terms in your series. So after finding the number of terms, I can just show you with this one actually. So 2k subtract 1. Let's see what kind of series it is. So if you substitute 0 here, you're going to have minus 1. If you substitute 1, you are going to have 1. If you substitute 2, you're going to have 3. So let's see the difference between these, all of these. So you can see from here to here, basically have 2. And from here to here, also have 2. So this is an arithmetic series, and you can see that d is equals to, so d is equals to 2. And we aren't going to start at 0. This is the 0 point. We're going to start at 1, and therefore the first term is 1. So let's say we were moving from 0 to 2. We obviously have 3 terms, and we want to apply this case 1 situation over here, where we find the sum or the result of the summation of 2k subtract 1 from 0 to 2, right? So this is what we want to find using the case which I introduced now. You can't use this, as I said, you can't use this 0 into the formula which we're about to form now. So we can use this formula over here because we don't know the last term. We're assuming that we don't know the last term. So let's just use this formula over here. So basically just going to substitute that your A is here as 1. And your D is 2. Right? So this is the formula. You can just simplify it if you want, but I'm going to work with it as it is for now. Now that you have this formula, you can proceed. This is true. You can proceed to find the sum at the first term. So the sum at the first term is simply the first term starting at 0. So you already have minus 1. Now we're going to add everything else, not individually, but just using this formula over here. So let's find the number of terms in this sequence. So number of terms, you have the number of terms equals to 2 subtract 0 plus 1, which means the number of terms is 3. Now that we already have 1 term here, we just have to find from the 0 point, we just have to find the sum of the next 2 terms. So where we see n, we're going to substitute 2, right? So that is what we're basically going to do. 2 divided by 2, this is going to be 1. So 1 multiplies the whole bracket. Then you have 2 in here, which is going to be 1. So the result is going to be 4 because you have 2 added to 2 over here. And the result of that is going to be 4. So now the answer to this, you first found the first part, which is the first step in the case 1 case. If this starts at 0, this is what you first do. So this is the 0 position. And then this is the summation of the rest of the series. So whatever number which you have, So from 0 to whatever number, you can just basically use the formula or the corresponding formula and find the sum from 1 up to whatever number. So that is what we basically did here. And the answer would therefore be 3. Now let's verify this answer using the simple, because now we can. Let's verify this answer using the simple method of just substituting everything. So let's come up here and say from 0 to 2. So 0, 1, and then finally we're going to substitute 2. So this, we have -1, then added 2. This should be 1 because it's 2 subtract 1. And then here we have 4 subtract that, which is 3. So in the end, we have -1 plus 1, which cancels out, which is equals to 3. So basically have the same answer. But you can't, as I said, you can't always do this because the top number or the last number which you're supposed to substitute might be too big. Imagine having to compute all of these if the top number was 50. You'd basically spend the whole time in your test trying to do that. So you are going to apply this formula or this method over here. If the segment notation starts at 0, you're going to take out the first number which you find after substituting 0 and then write it down. So that number added to everything else. And this everything else is the summation from 1 to whatever number. And to find the number of terms which you're supposed to substitute, you basically just say the top number subtract 0 to find where you should start or the number of terms that are left. So you find the total number of terms using this formula, which says number of terms is equal to n, subtract the bottom 1 plus 1, find the total number. Now that we've removed the 0 position, you are left with the number of terms subtract 1, right? So that is the number of terms which you're going to substitute into your summation formula over here, and then find the sum of the remaining terms. And then after that, you're basically going to add the one which you found after substituting 0 and add it to your summation, and that'll be your answer in step 3. Now, case 2, the second case, this is basically when you have a number. So you basically have a starting number which is 1 or greater. So let's say k greater equals to 1. So now if you have 1 or 2 or any number which is equals to or greater than 1 as your starting point, you basically just have to find the number of terms. So this is the first step. Basically just have to find the number of terms and say number of terms basically equals to n minus k plus 1. So this will be a number of terms. After finding the number of terms, you're just going to substitute the number of terms, into summation formula. So from the series which you have, whatever series you have here, you first have to identify the series, if it's arithmetic, if it's geometric or whatever. After identifying it, you're going to form a formula using what we previously discussed in the previous video. After forming that formula for the summation, you just substitute the number of terms. And then you're basically going to find the answer to your series, which is written in segment notation. And that is basically all about segment notation. Next, I'm going to talk about infinite geometric sequences. Right? Infinite geometric sequences. This is the last section before I do examples. So I'm gonna dedicate a whole video to doing examples about everything which I've been talking about in these 3 videos. So this is the last section. The word infinite, well, it basically means with no end, or it goes on and on and on and on and on and on. So what do we actually want to talk about in this case? We have 2 cases where a geometric sequence can be convergent, or where it converges, or where it diverges. And when it converges, we're basically saying that we can approximate a value which it reaches. So even if the geometric sequence is known to be infinite with no end, either grows or doesn't follow any particular pattern, if we can approximate a value, then we say it converges. If we cannot approximate a value, or if we can't associate a value with a certain geometric sequence which is known to be infinite, then we say that sequence diverges, right? And for a sequence, or for a geometric sequence to be convergent, it has to have a ratio which is between -1 and 1. So this is what you have to check for before you apply the formula, which I'm going to show you now. So if the geometric sequence does not have a ratio which is between -1 and 1, then it does not converge. If it has a ratio which is between -1 and 1, then it actually converges. And to find that convergent value, so to find the value which it converges, so a typical question would say, does the following geometric sequence converge? So the following infinite geometric sequence converge? And you basically just check or find the ratio. If you're not given the formula, you just have to find the ratio first. If you're given the formula, just take the ratio out of that formula and identify if it's between -1 and 1. And if it is, then you can say that infinite geometric sequence converges. Then after that, maybe they can ask you, what value does the sequence converge to? And that is where you apply this formula. So s to infinity is equals to a, which is your first term in your geometric sequence, it's the first term, divided by 1, subtract r, which is your ratio. And this formula should give you the value to which your geometric sequence converges to. And that is basically it from this video. The next video, as I said, will be about examples, about the videos which we've been talking about so far. If you haven't subscribed, please subscribe. And if you like this video, just go ahead and give it a thumbs up.